So for this section, we're going to be finding equations for vectors. And the vector equation consists of two important components. The first one is the starting point of the vector, and the second part is the direction of the vector over time, like times the time, so how long it will be traveling. So for this problem, for example, we can see that the vector is starting at 3, 4 right here and going 2, 5, 5 right here. So the starting point is 3, 4, while the direction is towards 5, 5, but is not 5, 5 as a point, it's towards that. So this is the equation format. Again, the time just means like it could be continuing, like, you know, could be like that's 1 unit of time, 1 hour, and then the vector can keep going, or, you know, it will just continue and get longer, so that's why the time is important. So direction represents just the slope. Like in the previous lesson, we said the change in x and the change in y, or in other words, that's the component vector. So to find the component vector, as we saw, we just gotta see how much it traveled horizontally and vertically. You know, find the component form of the vector. So horizontally, the vector traveled 2 units, and vertically traveled 1 unit. So the equation should look like 3, 4 plus t times 2, 1. Where 2, 1 is the component form of the vector, or the direction vector, in other words. So, for example, suppose an object is moving with constant velocity. The object is at 5, 3 when started, at 0 time, and it kept going, and after 3 units of time, whether 3 minutes, 3 hours, doesn't matter, the object reached the point -415 on the grid. Like, we'll, you know, assume it's an ant and walking on graph paper. And, you know, it's moving per second. So at 0 seconds, the ant was at the point 5, 3 on graph paper, and then it kept walking, constant velocity, and after 3 seconds it reached -415. Let's draw that. So it should look something like that. So when they say find the velocity, that means they need, or they want, the vector in component form. And when they say the speed, that means the magnitude or the length of the vector. And the vector equation is something we just learned right now. So let's try to find all of these three things. So to find the velocity, again, let's look at the component form of the vector. So to get from this point to the point -415, I have to go left and up, or up and left. So I'll need to go left 9 units and up 12 units to reach -415 from 5, 3. So left 9, that's -9, up 12, that's +12. So that's the component form. So now velocity means the slope for every 1 unit of time. And since the vector kept going for 3 seconds, that means for every second that was the constant velocity for every 1 second, or every 1 unit of time. So just looking at this, 3 seconds, that's not the vector as 1 unit of time, that's like 3 units of time. So I need just 1 second, so it will keep going, you know, -3 or left 3, up 4 and then negative 3 of 4, and then negative 3 of 4. Okay, so that's the velocity, negative 3, 4. Now to find the speed, I just got to find the magnitude or the length. And again, that's for 1 unit of time. So the speed is really the length of the velocity. So the length of the component vector over 1 unit of time. So we agreed that the velocity over here was negative 3, 4. So the speed would be negative 3 squared, or 3 squared, because since it's going to be squared, the negative doesn't matter, and 4 squared, and that is 9 plus 16, which is root 25, or 5. So 5 units per 1 second. It's the same as saying like 5 miles per hour, whatever the length is over 1 unit of time. Now, since we have all the information, let's just write a vector equation. The vector equation would be xy equals 5, 3 plus t negative 3, 4. Or in other words, starting at 5, 3 times however many time there is, and that's the direction and the velocity. So that means if I, for example, plug in 3 here and add those two components, I'll get negative 415. So if I want to know where was the object or the ant in 2 seconds, I would plug 2 here, multiply, and add 5, 3, and I'll know what point exactly was the ant. And again, if I want to know where the object was after half a second, or 1.5 seconds, or 3/4 of a second, all of that is possible to figure out. I'll just plug in the time, multiply, and then add the components, and I'll get the exact point of where the vector or where the object is. Next, we're going to be talking about parametric equations. And what a parametric or parametric equations are is taking the vector equation and breaking it in half. Part for x by itself and part for y by itself. For example, the equation that we just did, xy equals 5, 3 plus t times negative 3, 4. I can write this as two equations, one for x and one for y. I could say that x equals, just looking at the x components, 5 minus 3t. And I got that by just taking the x value and then taking negative 3 and multiplying to t here, because negative 3 is the x value. So x equals 5 plus t times negative 3, which is negative 3t. Similarly, the y values, y equals 3 plus t times 4, or 4t. And those two equations are called parametric equations, where t is the parameter. And what a parameter is that, we just choose a value to calculate a specific thing. Like in the previous problem, we, said to calculate where the object reached. We can plug in like the amount of time it has been traveling, like a 3/4 of a second, 1.5 seconds, all of that. So t represents that.